All right, hello everybody. Today we're gonna look at two objects, one on the table, one hanging off. So, situation like this where maybe you've had this happen where things are connected somehow, some way. One object falls off and then it pulls the other object with it. Okay, so we're gonna kind of look at how all that stuff works out. Okay, so. Object 1, mass of 10 kilograms. Object 2, mass of 12 kilograms. There's a coefficient of kinetic friction of object 1 of 0.5 from the table. So we're going to find two things. We're going to find the tension and the acceleration, okay, of the objects on the table. Okay. So two objects. So we're going to have two free body diagrams. Okay. So object 1, free body diagram. Object 2, free body diagram. Okay, so for object number 1, the one on the table, okay, we have weight pulling it down. I have a force normal directly up, and then the rope's on its right, so there's gonna be tension towards the right, and then there is friction due to the coefficient of friction. Bop, bop, bop. Okay. Object 2. Well, all I have is weight down, and then there's a rope, so there's tension up. That's it. Okay, so that part's done. So let's go to our part 2, the summation. So once again, I'll say object 1, summation of forces in the x equals ma, summation of forces in the y equals ma. And for object 2, I'm not going to do the summation of forces in the x because there is nothing in the x. It's all in the y. So summation of forces in the y equals ma. Okay. So let's walk through this. So for object 1, summation of forces in the x, tension, friction. Okay, so positive tension, negative friction equals ma. In the y-axis, normal weight, positive force normal, negative weight equals ma. Object 1's not being lifted up. It's pretty safe to assume it's just going to be dragged to the right, so that acceleration is going to be 0. So force normal is equal to weight for object 1. Object 2, all I got is tension and weight, so positive tension, negative weight equals ma. That's it. Okay. So let's kind of think about this. So friction I can solve for, and weight I can solve for. So friction, as a reminder, I'll put kind of up here at the top. Friction is equal to mu Fn, and weight is equal to mg. Okay, so for the friction here, okay, I have friction is equal to 0.5, so 0.5 times. Well, force normal is equal to weight, so I'll just do this, mass times gravity. So I have 10 times 9.8. That gives me 49 newtons. Okay, so really for object 1, I have tension minus 49 is equal to 10A. For over here, I have tension minus 12 times 9.8, 117.8 equals 12A. And really, actually, okay, let's talk about this 12A for a second. If object 1's being pulled to the right, okay, that then means object 2 has to be dropping down. So object 2 is actually going to have an acceleration that goes down, which means it's going to be a negative 12A. Ooh, that's important. All right, so I have two equations. I have t minus 49 equals 10A and the t minus 117.8 equals negative 12A. They're connected, so the tension should be the same, and because they're also connected, the acceleration, however fast this object accelerates down, will also be the same acceleration that this object is slides across the table towards the right. So, two equations, two unknowns. Just set them equal to each other. So let's get the tensions by themselves first. So actually, let's solve for the acceleration. I know it's the second thing listed, but we'll go a little cheeky and sneak on that. So for this one, tension is equal to 10a plus 49. And for here, tension is equal to negative 12a plus 117.8. So we're going to set these two equal via the tension. So boop, 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 set equal. So this gives me then 10a plus 49 equals negative 12a minus, or sorry, plus 117.8. Okay. So 22a is equal to 117.8 minus 49, 68.8, and then acceleration is equal to 3.13 meters per second squared. All right. Acceleration is that. So now it's just, I pick, do I want to plug it into this one? Do I want to plug it into that one for the solving for the tension? So I'll just pick this one. Why am I picking this one? I don't know. Why not? So times 10 plus 49. So tension is equal to 80.27. Once again, I'll just kind of say tension equals 10 times 3.13 plus 49 newtons. Boom. All right. Hi again. We're going to take a look at another question on this video. So kind of the same premise, two objects, but this time one is on an incline and one is hanging. So object one is sliding down the ramp. So object one is sliding down the ramp and pulling up object two. The mass of object one is 300 kilograms and object two is 50 kilograms. Coefficient of friction is 0.7. That's the coefficient for one. I know it's not stated, but like that should make sense. It's one touching the ground. What is the acceleration of object one? So we're trying to find the acceleration of this one. All right. So just like before, we have two objects. We're going to have two free body diagrams. So object one's though will be on an incline. I'll just do two right away. This one's really straightforward. You have weight down and tension up still. That's it. Okay. I'm actually also going to put upward acceleration being pulled up. Okay. Object one, okay, we have an incline. So we go through an incline process. We have weight straight down. We have normal, that is perpendicular to my surface. Let's see, tension's on the right. So tension. Also, if it's sliding down the incline and there's friction, coefficient, friction is that way as well. Then we have our two other forces of force parallel and force perpendicular. Okay. Hopefully this is going a little easier now that we've seen it a few times in these recent days. Okay, hopefully getting those clicked. So now let's go to our summation of forces. Summation of forces, oopsies. 1, 2. Summation of forces in the x equals ma. Summation of forces in the y equals ma. And then for object 2, I'm just going to do summation of forces in the y equals ma. This one is tension minus weight equals mass times acceleration. Okay? Just the two right there. For the y-axis, oopsies, sorry about that. For the y-axis, I just have the force normal, force perpendicular. So force normal is equal to force perpendicular. All right, because it's not being picked up, off. So let's go to the spatial force in the x. So this time, if we look at our thing, tension and friction are actually our positive forces, where parallel is my negative force. Now, that sounds a little weird, but actually that's the way this one works. So, force parallel minus, or negative force parallel plus tension plus friction equals ma. And now, is some solving action, okay? Because I could solve for force parallel, I could solve for friction, I could solve for weight over here. So let's just do some plug and chugging. I'll do the weight first. So tension, 8. So I have tension minus 490 is equal to 50A. This is staying positive, it's moving up. All right, going over here, I am doing this off screen. Just a quick reminder of our equations. Friction, force normal, force perpendicular is the mg cosine theta, and force parallel is mg sine theta. So I'm not going to like walk through these again, okay? You have them here. That's your mass, that's gravity, cosine your angle, 10 degrees, very, very shallow ramp. Okay, so that one's kind of a, let's get that bad boy on our own. And make sure we're in degree mode. Negative 510.53 plus tension plus 300 times 9.8 cosine of 10 times 0.7 is 2026.73 equals 300A. Okay. All right. I'll simplify this bad boy down. So that minus 510.525.653. So I have tension plus 1516.21 is equal to 300A. All right, let's just get these two bad boys equal. So my goal is to solve for the acceleration. So I actually need to get tension by itself. Sounds a little weird, I know. So add 490 over, subtract this over. So I have tension is equal to 50A plus 490. And I have tension is equal to 300A minus 1516.21. Now, let's think about this one, actually, before I go any further. So this object is sliding down the ramp. So because of that, this actually needs to be negative. I know I forgot to do that in my biologies. Okay, so that actually needs to be negative. So I'm going to throw a little negative on all of those. Okay, so let's set these equal. So I have negative 300A minus 1516.21 equals 50A plus 490. So now let's just combine some stuff. So I'm going to, I don't know, I'll just, I know it sounds weird. I'll do negative 350A equals, add the 1516.21. So 1516.21 plus 490 gives me a positive 2006.21. And then divide A is equal to, divide negative 350, negative 5.73 meters per second squared. Negative because it's sliding down, and in this case, down is to my left, so that makes sense. It worked out. Right. See you, kiddos.